Hello guys and girls, and welcome back to my video where I'm going to be explaining to you guys Tiles homework. Pretty fun activity. So before we get into it, let's first give a little overview of what it is. So let's see the Dr. Troller's website. Let's ignore this tab. Let's see here. So we're basically in a domino tiling where only two will be able to match. So if there's like some spaces sort of like this, it's not tileable, I believe. Wait, is this one tileable? Depending if these two are considered tiles. So we're given this example. You can actually figure it out via the examples he gives out. He gives you like a tiling.h, tiling.cpp, which contains the max float and augmented path, the vertex.h, and the main.cpp. So, few things to note is don't mess with the augmented path. Do we have accesses? It doesn't seem that I can click on this. This is quite odd. Let me backtrack a little. Can you guys click on it? You guys will figure it out. So let's get into this. So there's our little guideline that we need to follow. How it works: assigning vertex, connecting the vertex to source and sink, and the Boolean condition. Now, let's say you're given this. I know they look quite the same, but for examples right now, we need to visualize how it works. So I'm gonna start off with orange here, or red, I don't know. And each iteration I'm going towards, so I'm gonna make a black color right here, so I can separate these guys. So there's a highlighter still, and this is still red, and there we go. So I'm gonna be separating these guys. So, because, alright, controls. This go here, this go here. Alright, you know what? Forget it. I'm just gonna do this. So, what I'm trying to illustrate is you guys create these vertices. So, you have a group here, here, and here. And let's say, I believe there's 1, 2, 3, 4. Did I add the same one? 1, 2, 3, 4, 5. Alright, let me look at the. What is this? 1, 2, 3, 4, 5. Alright. So, first things first, let's create these tiles. So, right now I'm gonna be creating vertices. So, 1, 2, 3, 4, 5. 1, 2, 3, 4. So, which one of these do you think it's tileable? Well, this one's not tileable. This one is, because there's two. Two makes a tile, a domino. Mostly just set for that one. So, what are you gonna do? First things first. As you saw in Dr. Troller's example, you're gonna be doing the color pattern, which is what I recommend. So basically, you're going to have a red group and a blue group. And what I do is, what I first do is create vertices for everything. So if it's an empty, okay. When I say I create a vertex for everything, is that each one of these guys is a vertex. That's how I set it up to be. That's how I set my solution to be. They're all vertices. Just that, these guys, they're blank. So you don't need to really do my method of doing it, but that's how I did it. So these guys are just blank vertices. Don't worry about them. But I create these blank vertices with negative 100 values, meaning that some number. And I make different groups. One being the red group, the other one being the blue group. So let's go here. So right now, let's do this example. This is going to be my red, and this is the first vertex I found. The second one is going to be blue. The third one's going to be red. So it's going to look something like this. Blue, blue. Something like this, it's how it's going to look. But each time I'm moving a character, I'm going to change my color, my group. So right now, I start off at red, blue, red, blue, red, and then slash new. What would happen if I hit a slash new? Well, I do red is not equal to red. So the opposite of it. So it turns into a blue, red, blue, red, blue, slash new. And I do the same thing. B is not equal to B. And it becomes red, blue, red, blue, red. Now, is this tileable? Alright, I'm going to do B or B. Well, we know that all of these guys, everything in black is going to be a blank. So basically, these guys. So everything in black is going to be your little hashtags. And these guys, well, we can group them up because, well, there's a blue, there's a red, there's a blue, there's a red. We can group these guys up. It's fairly simple a task. So, first thing to do is assign the vertices. Now, what does this vertex have? I have sorting conditions on my vertex class where I have a group and location at where it's currently at. I forget what he gives you out because I can't really access it right now. But this group either is an integer value, a string, anything overall. So first things first, create these vertices. So no matter what, depending if you're red, blue, you're gonna be creating these vertices. So red, blue, red, blue. So similar to how you did in the maze, you're creating these vertices on blank spaces or empty spaces. What I do is I create hashtags, but these guys are called blank vertices, so I don't do anything about them. Now, that's mostly just it for this one. You don't do much. Right now you're creating, what you're doing is separating the work. So if it's not a hashtag and not a new line, create these vertices based on their how do I say this? Based on what they're supposed to be, like red, blue, red, blue, red, blue. What you're creating is basically a checker pattern. So you're creating a checker pattern. So there's going to be red, blue, red, blue, red, blue, red, blue. So I know I'm saying this a lot, but I just want you guys to understand what's happening. You're creating this whole maze into a checker pattern in which you're able to input certain things into it. So these checker patterns are going to be your vertices, and based on the group that you're assigned it to. It's a little bit confusing, but just create vertices based on these type of checker patterns of red, blue, red, blue, red, blue. You alternate once you hit a new line, blue, red, blue, red. Alternate when you hit a new line, red, blue, red, blue, blue, red, blah, blah. Now, when it comes to the sort and sync. Now, as you guys have learned in class, what would you do? Well, that's a good question. It's a very similar problem to your maze. Just in this case, let's say I'm blue. No. I iterate through my whole vertex, and because I have these blank things called blank vertices, meaning my hashtags or new lines or whatever, I have a group. And if group is, this ID. Let me see. What do I assign my group here? Let's see here. Well, group. I believe. Yes. I assigned group to 1 because it represents true. Correct. Correct. Right. I assigned group to 1 because it's we're going to group it. Yeah. So it's like a boolean, like, hey, is this groupable? And then you check, like, is this red or blue? Red or blue? So, what group am I at? So, okay, let me rephrase this. I'm going to iterate through my whole vertex set. And I'm going to check, hey, is this a vertex that has something in it? It's not a blank vertex, or it's a vertex with items that exist. Because, I had these blank spaces, blah, blah. Now, I check, hey, this belongs to some certain group. Does it belong to the red group or the blue group? Well, if it's in the blue group, then it's true. If it belongs in the... No. If it belongs in the red group, it's 1, which is true. If it belongs in the group blue... the blue group, it's false, which is false. Well, check what group. Check what group you're a part of. If you're either in the red group or in the other group, what you're going to do is you're going to assign this start to... Okay. You're going to... So, okay. Let me rephrase this again. So you have these 2 conditions. Your start or source. And your other condition is going to be, your sync /end. And you basically have these vertices. So let me get the color for it. So right now I'm going to assign my start to red vertices. And then I'm going to assign all my blue ones to be close to sync. So this is what I'm trying to create. Now, what we can do is like we're gonna link all the vertices that are from group red to the source and group all my vertices that are in group blue to my sync. And then once I'm done with that, I do a check. Because you know how you have these vertices, right? They have a neighbor above them, to the left of them, to the right of them, and below them. You don't know what, but the thing is that they're already created. The whole map is a group of vertices now, just that you're connecting specific ones. So, and also you don't have to worry about like, hey, is this in group blue, red, whatever? It doesn't matter. I believe, right? Let me double check. No, it doesn't matter. You just check up. Hey, is this something I can, modify? Is there something above me? I can connect them. And, I don't know, check if there's something. Now, what I mean by something is like they're not a hashtag or something. Now you would insert the neighbors with a weight of 1. This one has a weight of 1, this one has a weight of 1, weight of 1, weight of 1, weight of 1. That's the weight of it. Now you're going to do up, left, right, down. You're going to get the location in your vertex set. do a find, and if it's not equal to end, like the the vertex x dot end, then you're good. Now, yeah, you just connect them because it's a a simple connection. Because these guys go to these guys go to these guys go to these guys go to these, bunch of funny looking guys. Now, like the Boolean condition, what the thing you're returning. So my return. So like my return. Well, you guys did this in a similar quiz. So what would happen? Well, v.size. What I do is I don't know if this is correct or not, but I do v.size is equal to 0 because it means that. What is v? What is v in this case? Let me double check my code just so I don't give you guys incorrect information. My v is an unordered set, so I think it just gathered a bunch of things. So I do that. V needs to be divisible by 2, and your counter divided by 2 needs to be equal to max flow. Why is this? Well, what is my counter in this case? I think counter is just the groups. Let's see. So counter is basically all the vertices from group red and blue, and you just want to check if it's divisible by 2 and it's equal to the max flow, because red group red and blue, they need to be tileable, so they each have a pair. You divide it by 2, it's equal to if it equals to the max flow. So that's mostly the Boolean condition when you're returning, and it's quite a simple algorithm. If you guys have any issues with it, just tell me. But you guys understand the gist of it. So basically, you're making a checker pattern. You're making a checker pattern, connecting them. You're connecting all the red groups to the sink, all the blue groups into the, all the red groups into the start source, or all the blue groups into the sink and end. Then your Boolean condition, hey, is this equal to my max flow? And that's mostly just it for the assignment. So, thank you guys for watching and hope you guys enjoyed. Hit that subscribe button and see you guys next time.